Welcome to Math with Mr. J.
In this video, I'm going to go through a mini course on fractions, and we will be looking at some of the most important concepts when it comes to working with fractions. Things like important and common vocabulary, equivalent fractions, simplifying fractions, converting between improper fractions and mixed numbers, and then adding, subtracting, multiplying, and dividing fractions. Everything is put into chapters and time stamped, so feel free to jump around. Now, am I going to go through every single thing we need to know about fractions? No, this is meant to be a refresher, a review of some of the more important concepts when it comes to working with fractions. This will give us a good base to build off of. So maybe it's been a while since you've worked with fractions, and now you're coming across them again, maybe in high school, college, or continuing your education as an adult, or even if you're new to fractions. Wherever you're at, fractions show up all throughout math. And understanding these concepts will be very helpful moving forward. Let's start with some common language, some common vocabulary when it comes to fractions. Let's jump into number one, where we have numerator and denominator. Let's use 3/4 for this example. Now, the numerator of a fraction is the top number. The denominator of a fraction is the bottom number. So 3 is the numerator and 4 is the denominator. And one way to help remember these is to think denominator down. So we have the d's. And then since the denominator is the bottom number, the numerator has to be the top. Moving on to number two, we have proper fraction and improper fraction. Let's start with proper fraction. Now, a proper fraction is a fraction where the numerator is less than the denominator. So the top is less than the bottom. And the value of a proper fraction is going to be less than 1. For example, 5/8 is a proper fraction, 19/20 is a proper fraction, and 1/10 is a proper fraction. All of these fractions have a numerator that is less than the denominator. They are all less than 1 whole. So these are all proper fractions. As far as an improper fraction, the numerator is going to be greater than or equal to the denominator. So the top is going to be greater than or equal to the bottom. And an improper fraction has a value that is either greater than or equal to 1. For example, 7/4 is an improper fraction, 15/9 is an improper fraction, and 10/10 is an improper fraction. So these are all examples of improper fractions. Again, improper fractions have a value greater than or equal to 1. The numerator is greater than or equal to the denominator. Next, for number three, we have mixed number. A mixed number has a whole number and a fraction. For example, 2 and 1/3, 10 and 7/8, and 1 and 3/5. So those are all examples of mixed numbers. Again, they are made up of a whole number and a fraction. Moving on to number four, we have equivalent fractions. Now, equivalent fractions are fractions that have different numerators and denominators, so different names, so to speak, but they have the same value. For example, 2/4 is equivalent to 1/2. You can see that both of those fractions, they have different numerators and denominators. They have different names, but they are equal in value. Another example would be 3/9 and 12/36. And then also 7/8 and 21/24. So equivalent fractions are fractions with different numerators and denominators, but they still have the same value. Moving on to number five, we have simplified fraction, which you may also hear a fraction in lowest terms. These mean the same thing. Now, as far as what a simplified fraction means, That means the greatest common factor between the numerator and denominator is 1. Now, this isn't the most technical or mathematical way to put it, but basically, the only common factor is 1 means the only number that can go into both the numerator and denominator is 1. We can only divide by 1. If that's the case, a fraction is in simplest form. Basically, a simplified fraction is the simplest version of a fraction, the lowest numbers we can get to, and the fraction still has the same value. For example, if we have the fraction 15/30ths, we can simplify this. The greatest common factor between 15 and 30 is 15, so we can divide the numerator and denominator by 15 in order to simplify. So the greatest common factor of 15 means that 15 is the greatest number that goes into the numerator and denominator, the greatest number that we can divide both by. 15 divided by 15 gives us a numerator of 1. 30 divided by 15 gives us a denominator of 2. So the simplified version of 15/30ths is 1/2. The only common factor between 1 and 2 is 1, so this fraction is simplified. Another example would be 18/20ths. 18 and 20 have a greatest common factor of 2, so we can divide both of these by 2 in order to simplify. 18 divided by 2 is 9. 20 divided by 2 is 10. The only common factor between 9 and 10 is 1, so this fraction is simplified. And then one more example here. Let's say we have the fraction 3/4. This fraction is already simplified. The only common factor between 3 and 4 is 1, so this fraction is already in simplest form as is. So a simplified fraction, or a fraction in lowest terms, just means that the fraction is being represented by the simplest, lowest numbers possible. The only common factor between the numerator and denominator is 1. And then lastly, for number 6, we have like fractions and unlike fractions, or you may hear like denominators and unlike denominators. Let's start with like fractions. Now, like fractions are fractions with the same denominator, also called a common denominator. For example, 1/8 and 3/8 are like fractions. They have the same denominator of 8. They have a common denominator of 8. Another example, 11/15 and 7/15. So again, like fractions have the same denominator. So these are our examples. Unlike fractions are fractions that do not have the same denominator. So fractions like 9/10 and 2/3, or 1/4 and 1/30. These are examples of unlike fractions. So like fractions, like denominators, or common denominators all mean that the fractions have the same denominator. And then unlike fractions or unlike denominators mean the fractions have different denominators. So there's some common vocabulary when it comes to fractions. Let's move on to equivalent fractions. Now let's take a look at equivalent fractions. And like we talked about in the first section, basically, equivalent fractions are fractions with different names, but they have the same exact value. We're going to take a look at how we find equivalent fractions using multiplication or division. So let's jump into number 1, where we have probably the most common and well-known fraction, 1/2. We're going to find 3 equivalent fractions to 1/2. Now, we cannot use division for 1/2 because there is nothing we can divide 1 and 2 by, our numerator and denominator. The only common factor is 1. So we're going to have to use multiplication. So let's multiply our numerator and denominator by 2 in order to get our first equivalent fraction. So multiply by 2, and we get, well, 1 times 2 is 2, and then 2 times 2 is 4. 2/4 is equivalent to 1/2. Those fractions have different names. We say them differently, 1/2 and 2/4, but they have the same exact value. Let's try another example here. Come to the right, and let's multiply both our numerator and denominator by 5. So we end up with, well, 1 times 5 is 5, and then 2 times 5 is 10. 5/10 is equivalent to 1/2. Different names, same value. One more example, so we will come underneath here, 1/2, and let's multiply both our numerator and denominator by 100. So we end up with 1 times 100 is 100, and then 2 times 100 is 200. So 100 200ths is equivalent to 1/2. To be clear, we can only use multiplication or division when it comes to equivalent fractions. Addition or subtraction will not give us an equivalent fraction, so keep that in mind. And when it comes to equivalent fractions, we have an infinite amount of equivalent fractions for any given fraction. Because multiplication, well, we can multiply by anything. As long as we do it to both the numerator and denominator, we get an equivalent fraction. Now, division is a little more limited. It depends on that first given fraction if we can use it. But again, that multiplication really opens up our possibilities and gives us an infinite amount of equivalent fractions. Let's move on to number 2, where we have 5/15. Now for 5/15, we can use multiplication or division. We can use division for this one because we have something we can divide both 5 and 15 by. We can divide both of them by 5. So let's do that and see what equivalent fraction we get. So 5 divided by 5, and then 15 divided by 5. 5 divided by 5 gives us 1. And then 15 divided by 5 gives us 3. So 1/3 is equivalent to 5/15. Let's use multiplication as well to find 2 more examples of equivalent fractions to 5/15. So I'll come to the right here, rewrite our original fraction, and let's multiply both by 3. So 5 times 3 gives us 15. And then 15 times 3 gives us 45. So 15/45 is another example of an equivalent fraction to 5/15. And then lastly, let's multiply by 10. So times 10 times 10, and we get 5 times 10 is 50. And then 15 times 10 is 150. So 50 150ths, another example of an equivalent fraction to 5/15. Let's move on to numbers 3 and 4, where we have a given fraction and then part of an equivalent fraction. We need to find the missing part of those equivalent fractions. So for number 3, we have 3/4 equals how many 16ths? So we need to look at what we're given. We're given both denominators. We have a 4 and a 16. We need to take a look at how do we get that 4 to equal 16? And then we need to do that same exact thing to the numerator in order to get an equivalent fraction. Well, we know that 4 times 4 equals 16. So let's do the same exact thing to the numerator. 3 times 4 gives us 12. So 12 is our missing number there. 12/16 is equivalent to 3/4. And lastly, let's move on to number 4, where we have 18/21 equals 6 and then a missing denominator. So we need to take a look at what we're given, and we're given the numerators. So we have an 18 and a 6. So let's think, how do we get 18 to equal 6? Well, 18 divided by 3 equals 6. divided by 3. So we need to do the same thing to the denominator in order to keep this equivalent. So we have 21 divided by 3, that equals 7. So 6/7 is equivalent to 18/21. So there's an explanation of equivalent fractions. Let's move on to simplifying fractions. Now we will take a look at simplifying fractions. Let's jump into our examples, starting with number 1, where we have 4/8. So when it comes to simplifying fractions, we are looking to get the smallest numbers in value that we possibly can for our numerator and denominator. We do this by finding common factors between our numerator and denominator, numbers that we can divide both our numerator and denominator by. Once the only common factor is 1, we are in simplest form. So for number 1 here, I'm going to write out the factors for both 4 and 8, and then we'll go from there. Now you do want to get to the point where you do not need to write out the factors when simplifying, but again, for this one, I will. We'll start with 4, so let's come down here. So when it comes to factors, we need to think all of the numbers that we can multiply together to equal 4, or all of the numbers that 4 is divisible by. You can also think of it as all of the numbers that go into 4, so to speak. So we can start our factor list with 1 and then the number itself, 4, because we know that 1 times 4 equals 4. Or you can think of it as 1 and 4 go into 4. So you can always start with 1 and the number itself. So let's think if there are any other factors. Well, we know 2 times 2 equals 4, or we can think of it as 2 goes into 4. So 2 is a factor. And those are all of the factors of 4, 1, 2, and 4. Now let's list our factors of 8. So we can start with 1 and then 8. I'll leave a gap in there so we can fill in any other factors. Well, we know 2 times 4 equals 8, or we can think 2 and 4 go into 8. We can divide 8 by 2 and 4. So let's put 2 and 4. And those are all of the factors of 8, 1, 2, 4, and 8. So we want to use the greatest common factor between 4 and 8 here. That way we can simplify in one step. So the greatest common factor is 4 here. So let's divide both our numerator and denominator by 4 in order to break this fraction down and get it into simplest form. And remember, if you divide both your numerator and denominator by the same number, we are going to get an equivalent fraction. So we are not changing the value of the fraction when we simplify. 4 divided by 4 is 1. 8 divided by 4 is 2. So we have 1/2. Now the only common factor between 1 and 2 is 1. So this is in simplest form, and we are done. So 4/8 in simplest form is 1/2. Now I do want to show you another path that we can take in order to simplify this fraction. So let me rewrite 4/8 here. Now another common factor is 2. So what happens if we divide both 4 and 8 by 2? So let's do this. Divide by 2, divide by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. So we get 2/4, which is different than 1/2. But we still have a common factor of 2. So we can divide by 2 again. And we get 2 divided by 2 is 1. 4 divided by 2 is 2. So we get 1/2 that way as well. So something to keep in mind. There can be different paths to get to the simplest form of a fraction. Now, if you use the greatest common factor between your numerator and denominator, you will simplify in one step. If you use a factor that is less than the greatest common factor, it will take more than one step. Let's move on to number 2, where we have 6/15. Let's write out the factors for 6 and 15. So we need to think all the numbers that we can multiply. Let's start with 6. all the numbers we can multiply to equal 6, or all of the numbers we can divide 6 by, all of the numbers that go into 6, so to speak. So always start with 1 and the number itself, put a gap in between, and your spacing and ability to think of factors will get better the more you do. So let's think if there are any other factors of 6. Well, we know 2 times 3 equals 6, so 2 and 3 are factors of 6, and those are the factors of 6, 1, 2, 3, and 6. So let's list the factors of 15. So we have 1, and then the number itself, 15. What other factors of 15 are there? Well, 3 and 5. 3 times 5 equals 15, or we can think that 15 is divisible by both 3 and 5. We are able to divide 15 by both 3 and 5, and it works out without a remainder. So let's look for any common factors. Well, 1 is a common factor, but we want something greater than 1. We have a greatest common factor of 3. So let's divide our numerator and denominator by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. Now, the only common factor between 2 and 5 is 1, so we are done. We are simplified. 6/15 in simplest form is 2/5. Now, one more thing I do want to mention is that a fraction can already be in simplest form. So, for example, if you have the fraction of 3/4 and you are looking to simplify, that is already in simplest form. The only common factor between 3 and 4 is 1, so that would be in simplest form as is. So something else to keep in mind. So there's an explanation of simplifying fractions. Let's move on to converting between improper fractions and mixed numbers. Now let's take a look at converting between improper fractions and mixed numbers. We will start with converting improper fractions to mixed numbers and then move to converting mixed numbers to improper fractions. Now when converting between these, keep in mind that they are always going to be equivalent. For example, if we convert a mixed number to an improper fraction, both the mixed number and improper fraction are equivalent. They are just in different forms. Depending on the situation or type of problem, sometimes we want to have improper fractions and sometimes we want to have mixed numbers. So we need to be able to convert between them. Let's jump into our examples, starting with number 1, where we have 11/3. This is an improper fraction. The numerator, the top number, is greater than the denominator, the bottom number. This means we have a value greater than 1 whole. Let's change this to a mixed number. We do this by dividing. We divide the numerator by the denominator. So 11 divided by 3. Now, once you have this down, you'll be able to do it without writing it out. But for this one, let me write out the problem. So we have 11 divided by 3. So how many whole groups of 3 out of 11? Well, 3, that gets us to 9. That's going to be the whole number portion of our mixed number. So 3 whole groups of 3 out of 11. 3 times 3 is 9. And we end up with a remainder of 2. We did not hit 11 exactly. So that remainder is going to be our numerator. And then we use the original denominator of 3 for the denominator of our fractional part of the mixed number. Always check to see if you can simplify the fractional part of a mixed number. 2/3 is in simplest form, so we are done. Let's move on to number 2, where we have 46/10. So again, we need to divide 46, the numerator, divided by 10, the denominator. Let's write this one out as well. So we have 46 divided by 10. So we need to think, how many whole groups of 10 do we have in 46? Well, 4. That gets us to 40. 4 whole groups of 10. So that's our whole number for our mixed number. Now, we do not hit 46 exactly. We have a remainder, something left over. So 4 times 10 is 40. Let's subtract, and we get 6. So a remainder of 6. That remainder is our numerator, and we use our original denominator of 10 for our mixed number as well. Now, the fractional part of the mixed number for number 2 can be simplified. We have a greatest common factor of 2 for the 6 and 10 here. So we can divide both of these by 2, and we get 4. 6 divided by 2 is 3. 10 divided by 2 is 5. So our final simplified mixed number is 4 and 3/5. Let's move on to numbers 3 and 4, where we have mixed numbers, and we are going to convert them to improper fractions. And we do this by multiplying and then adding. So I'll show you the process first, and then show you how and why it works. So we start at the bottom and work our way up. We multiply and then add. So 5 times 4 is 20, plus 2 is 22. So that is our numerator. Again, we did 5 times 4 is 20, plus 2 is 22. We keep the denominator of 5 the same. So 22/5 is our improper fraction. And the reason this works is because let's think of 4 wholes. Now, I'm going to write out 4 wholes as a fraction using this denominator of 5. So, for example, 1 whole would be 5/5. And I'm picking 5 because that's our denominator. So this is going to make it easier just using that denominator. Now we have 4 wholes. So 5/5, 5/5 plus 5/5. That would represent 2 wholes, but we need 4. So let's do another one. There's 3 wholes. 4 wholes plus our fractional part of 2/5. So these right here represent the 4 wholes. Then we have the fractional part, 2/5. So let's add all of these up. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, plus 2 is 22, and our denominator is 5. So we can see that we got 22/5. Now, using this method right here is a lot quicker. It's a shorter way than writing everything out. So again, multiply and then add. Let's try another one and move on to number 4, where we have 7 and 1/8. So we start at the bottom and work our way up. We multiply and then add. So 8 times 7 is 56, plus 1 is 57, and then we keep our denominator of 8. So 57/8 for number 4. So there's how to convert between improper fractions and mixed numbers. Let's move on to adding fractions, subtracting fractions, multiplying fractions, and dividing fractions. Now for this section, we will start with adding fractions and then move to other operations. We will do 2 examples for each. Check the description for links to other examples and explanations if you'd like more about any of these operations. Let's start with adding fractions and jump into number 1, where we have 3/7 plus 2/7. Now, when we add fractions, we have to have a common denominator. So we always look to see if our denominators are the same. If they're the same, we can add. So in the case of number 1, we have a 7 and a 7 for our denominator. So we have a common denominator right away. That means we can add. So we add the numerators. 3 plus 2 is 5. So this is going to equal 5. And then we keep our denominator the same. 5/7 is our answer. We can always look to see if we can simplify. The only common factor between 5 and 7 is 1, so we are done. 5/7 is in simplest form and our final answer. Again, for number 1, we had a common denominator of 7, so we were able to add right away. Let's move on to number 2, where we have 4/9 plus 1/6. So for this one, we do not have a common denominator in our original problem. So we need to find a common denominator and then rename both of our fractions with that common denominator before we can add. Now we're going to find a common denominator between 9 and 6 by finding the least common multiple between 9 and 6, and that's going to be our least common denominator. You may be able to think about what that least common multiple is, but as a review, let's write out some multiples of both 9 and 6 in order to find that least common multiple. And again, that's going to be our least common denominator. So I'm going to come to the bottom here. So 9 and 6. Now we can list the multiples of 9 and 6 by just counting up by 9 and 6. Multiples go on forever, so what we can do, we can just start with 4 or 5, see if we have any in common, and then we can go from there. So let's write out 4 multiples of 9. So 9, 18, 27, 36. Let's write out 4 multiples of 6, and then see if we have any in common. So 6, 12, 18, 24. It looks like we have 18 in common here. And that's going to be our least common multiple. We're going to use that for our common denominator. So I'm going to rename these fractions underneath the original problem with that denominator of 18. So when we rename, we're going to use equivalent fractions. So we're not changing the value of the problem at all. We need to think, how do we get 9 to equal 18? Well, 9 times 2 is 18. Whatever we do to the bottom, we have to do to the top in order to keep this equivalent. So 4 times 2 is 8. 8/18 is equivalent to 4/9, but we renamed that original fraction of 4/9 with that common denominator of 18. So again, we're not changing the value of the problem at all. We're just renaming with that common denominator so we can add. Let's do 1/6. So how do we get 6 to equal 18? 6 times 3 is 18. So we need to do the same thing to the top in order to keep this equivalent. 1 times 3 is 3. Now we have the fractions in our original problem renamed with that common denominator of 18. So we can add. Let's add our numerators. 8 plus 3 is 11. And then we keep our denominator of 18 the same. Always look to see if you can simplify. 11/18, the only common factor between 11 and 18 is 1, so we are in simplest form, and this is our final simplified answer, 11/18. That's how we add fractions. Let's move on to subtraction. Here are our subtraction examples. We'll start with number 1, where we have 8/10 minus 3/10. Now, just like when we add fractions, we need a common denominator in order to subtract fractions. For number 1, we have a 10 and a 10 for our denominators. So we have a common denominator in our original problem, so we can go ahead and subtract. For our numerators, we have 8 minus 3. That gives us 5. So this equals 5. And then our denominator of 10 stays the same. So we get 5/10, and that's our answer. But we can simplify here. We have a common factor other than 1 between 5 and 10 that we can divide both of those by. We have a greatest common factor of 5. So let's divide both of these by 5 in order to simplify. 5 divided by 5 is 1. And then 10 divided by 5 is 2. So we get 1/2 for our final simplified answer. Let's move on to number 2, where we have 11/12 minus 1/3. Now for this problem, we do not have a common denominator between our original fractions that we're subtracting. So we need to find a common denominator and then rename these fractions with that common denominator in order to subtract. Now we can find a common denominator by finding the least common multiple between 12 and 3, and that's going to be our least common denominator. Now you may be able to think about what that least common multiple is without writing out lists of multiples for both 12 and 3, but as a review, I'm going to write out some multiples of both 12 and 3 in order to find that least common multiple. So let's come below here, and we have 12 and 3. Now my suggestion is to write out 4 or 5 multiples for both 12 and 3, see if we have any in common. If not, we can always extend our lists. Multiples go on forever, so again, my suggestion, start with 4 or 5 and then go from there. So let's start with 12, and we can list the multiples of 12 by just counting up by 12. So let's do 4 here. 12, 24, 36, 48. Now let's do 4 multiples of 3 and see if we have any in common. So 3, 6, 9, 12. And we have 12 in common. That's our least common multiple. So that's going to be our least common denominator. So let's go back up to the original problem. And underneath here, we're going to rename our original fractions with that denominator of 12. Now 11/12 already has that denominator of 12. So we do not need to rename. We can just bring our 11 down. Again, that's because we already have that denominator of 12. Now as far as 1/3, we need to rename that. We're going to use equivalent fractions here. We're not going to change the value of the problem at all. So we need to think, how do we get 3 to equal 12? Well, 3 times 4 is 12. Whatever we do to the bottom, we have to do to the top in order to keep this equivalent. So 1 times 4 is 4. 4/12 is equivalent to 1/3. So again, we're not changing the value of the problem at all because we're working with equivalent fractions. Now we have that common denominator of 12, so we can subtract. 11 minus 4 is 7, and then we keep our denominator of 12. 7/12 is our final answer. Always look to see if we can simplify. The only common factor between 7 and 12 is 1, so this is in simplest form, and our final simplified answer, 7/12. That's how we subtract fractions. Let's move on to multiplication. Here are our multiplication examples. We'll start with number 1, where we have 3/8 times 2/5. Now when we multiply fractions, all we need to do is multiply straight across. So numerator times numerator, the top numbers, and then denominator times denominator, the bottom numbers. Once we do that, we can look to simplify if need be. So let's multiply our numerators first. So 3 times 2, that gives us 6. And then 8 times 5, that gives us 40. So we get 6/40. Now 6/40 is our answer, but we can simplify here. 6 and 40 have a common factor other than 1 that we can divide both our numerator and denominator by. We can divide both of these by 2. 2 is our greatest common factor. So let's divide both of these by 2. And we get 6 divided by 2 is 3. 40 divided by 2 is 20. So our final simplified answer is 3/20. 20ths. Let's move on to number 2, where we have 4 times 4/9. So we have a whole number times a fraction. Now we need to rewrite that whole number as a fraction before we start. Now, in order to put a whole number in fractional form, all we need to do is put it over 1. So let's rewrite this problem. 4 over 1 is 4. It has a value of 4. Again, it's just in fractional form. And we want to do that. That way we have a numerator and a denominator, and we can multiply straight across. Let's bring down our multiplication sign and the 4/9. Now we can multiply straight across. 4 times 4 is 16. 1 times 9 is 9. So we get 16/9. And that's our answer, but it's in the form of an improper fraction. So we want to convert this to a mixed number. And we do that by dividing our numerator, the top number, by the denominator, the bottom number. So 16 divided by 9. So we need to think, how many whole groups of 9 are in 16? Well, 1. That gets us to 9. And we have a remainder of 7. So that's our numerator of the fractional part. And then we keep our denominator of 9 the same. So 1 and 7/9 is our final answer. We can always look to see if we can simplify the fractional part of a mixed number. 7/9 is in simplest form, so we are done. Now, I do want to do a quick recap of how I converted from that improper fraction to the mixed number, and I'm going to write everything out. So let's come below here. I did our numerator 16 divided by 9. So how many whole groups of 9 in 16? Well, 1. That's our whole number right here. 1 times 9 is 9. We do not hit 16 exactly. We have a remainder of 7. So remainder 7. That remainder goes right here. It's the numerator part of our fraction. And then we keep our denominator of 9 the same. This 9 right here, we keep it the same. So 1 and 7/9 as our final answer. That's how we multiply fractions. Lastly, let's move on to division. Here are our division examples. We'll start with number 1, where we have 1/2 divided by 5/6. Now we're going to use the steps keep, switch, flip in order to divide fractions. Now you may also hear keep, change, flip, switch, or change. They both mean the same thing, and it's the same process. Now this is also known as multiplying by the reciprocal. So let's rewrite this problem using those steps and see exactly how we divide fractions. So we always keep whatever comes first. So we have 1/2. So let's rewrite 1/2 underneath. We keep. Then we switch or change to the opposite of division, which is multiplication. So let's write a multiplication sign. And then for our second fraction, we flip that fraction. That's called the reciprocal. So the bottom number, the denominator, is going to be the numerator. And the numerator is going to be the denominator. So our 6 goes on top and the 5 goes on the bottom. Now we're set up and we can multiply straight across. 1 times 6 is 6. 2 times 5 is 10. So we get 6/10. Now 6/10 is our answer here, but we can simplify. We have a common factor other than 1 that we can divide both 6 and 10 by in order to simplify. And that common factor is 2. So let's divide 6 and 10 by 2 here in order to simplify. 6 divided by 2 is 3. 10 divided by 2 is 5. So our final simplified answer is 3/5. So again, keep, switch, flip. Then we can multiply straight across and then look to simplify if necessary. Let's move on to number 2, where we have 3 divided by 4/7. So keep, switch, flip. Now we have a whole number here, and we need to rewrite that as a fraction when we keep it. And we do that by putting it over 1. And it's as simple as that. So 3 over 1. That still has a value of 3 wholes. Again, it's just in fractional form. That way we have a top and a bottom, and we can go through our steps. Then we switch or change. And then with the second fraction, we flip. So the 7 is our numerator, and the 4 is our denominator. So 7 up top, 4 below. Now we can multiply straight across. 3 times 7, 21. And then 1 times 4 is 4. So we get 21/4, which is our answer, but it's in the form of an improper fraction. So let's convert this to a mixed number. And we do this by dividing our numerator, 21, by the denominator, 4. So this is going to equal, how many whole groups of 4 can we pull out of 21? Well, 5 whole groups of 4. That gets us to 20. We have a remainder of 1. That's our numerator. And then our denominator of 4 stays the same. So we get 5 and 1/4. Now let me go through how I converted that improper fraction to a mixed number one more time. I'm going to write it out. So we do 21 divided by 4. So how many whole groups of 4 in 21? Well, 5. That gets us to 20. 5 times 4 is 20. Subtract, we get a remainder of 1. So this 5 is our whole number, 5 whole groups of 4 in 21, and then our remainder of 1 is the numerator of our fraction. We keep our denominator of 4 the same. Our final answer as a mixed number, 5 and 1/4. Now we can always look to see if we can simplify the fractional part of a mixed number. 1/4 is in simplest form, so we are done. Now one more thing I do want to mention is when we have a fraction that comes first and then a whole number that comes second. So let's do a quick example, and I'll just call this number 3. So we'll come over here where we have some room, and let's do 1/2 divided by 4. So keep, switch, flip. Keep the 1/2, switch to multiplication, and then we need to flip that 4, the reciprocal of 4. So what we do in this case, we put our whole number over 1, we put it in fractional form like we talked about for number 2, and then we flip. So the 1 is our numerator and the 4 is our denominator. So we have 1/4 for our reciprocal or flipped fraction. Then we can multiply straight across. 1 times 1 is 1. 2 times 4 is 8. 1/8 is in simplest form, so we are done. So you can see the difference there between whole number divided by a fraction and then a fraction divided by a whole number. It's always keep, switch, flip. Don't worry about if a fraction, whole number, or mixed number comes first or second. It's always those 3 steps in that order. So something to keep in mind. So there you have it. There's a mini course on fractions. I hope that helped. Thanks so much for watching. Until next time, peace.